Hello everyone, greetings and welcome to our webinar. It brings me a great pleasure to have you all in attendance today as we explore an insightful program. Our speaker for this event is one of our well-experienced engineer Pritham, who has been an integral part of this project for an extended period. As we commence, I would like to highlight the importance of your involvement and contribution to this webinar. If you have any queries or need further clarifications, please do not hesitate to raise them in the Zoom chat and we will answer them during the QA segment. Without any further delay, let us proceed with the program. I would like to hand over to our speaker, Pritham, who will provide valuable insights regarding this topic. Over to you, Pritham.
Hello everyone, I'm Pritham, currently working as a software engineer at AppScode, and today I will demonstrate a Solr ops request data lifecycle management for Solr cluster using KubeDB. So this webinar will be divided into some sections. First of all, I will give a short introduction about Solr. Then I will explain how KubeDB manages Solr. Then I will give a short description about Solr ops requests, to be specific, the ops requests that are supported by KubeDB for Solr. Then I will go through the live demo, and finally we will have a short Q&A session. So first of all, Solr has certain components. So first of all, like any other database, Solr facilitates searching and querying. Then it also supports faceting, which is to be specific, categorizing search results on the basis of certain keywords. Then it also has support for NoSQL we can search and query there. So obviously it's NoSQL DB, and documents are actually flown in the form of docs. After that, it also supports tokenization. Means it can actually trim gerunds or suffixes from keywords. And finally, it also supports advanced analysis, like it can analyze structured or non-structured data. So this is the architecture of Solr. First, Solr is basically a wrapper on Apache Lucene. So it has some components here. First of all, it has a request handlers. Any requests which are sent to Solr are processed by this section. After this, obviously, if we have sent any request, Solr will provide us a response, and that response we can be formatted in XML or JSON or binary. And then also we have update handlers. Update requests are specifically processed by this component. Basically, the request handlers actually provide the requests which are update requests to this component. After that, we have extract request handlers, and that means it will extract the keywords from the request handlers, and it's a wrapper on Apache Tika. And after that, we have search components as well, which facilitates querying, spelling, or faceting. And after that, I will move to how actually the operations KubeDB supports for Solr. So KubeDB supports provisioning, which actually ensures that a database is accepting connections, and we can read and write in the database as well. And then we have some ops requests here. First of all, it's update version. We can update the version of that database. Basically, we change the image of the database change the image of the custom resource in this case. And then we have vertical scaling. It deals with the increase and decrease of memory and CPU. Then we have horizontal scaling, which deals with the number of pods in the cluster. And then we can also change the default configuration of our database, and this ops request is called reconfiguration. Then we can also expand the volume of the PVC in the cluster, and this ops request is called volume expansion. And finally, we have auto scaling, which deals with the automatic vertical scaling and horizontal scaling on the basis of Prometheus and matrix configuration. We also have monitoring and TLS support for our Solr cluster in KubeDB. Then when we are running Solr in KubeDB, we also need Zookeeper here as well. So this is not the agenda of our webinar today, but yeah, you can go through the KubeDB documentation to get an overview of how to run Zookeeper in KubeDB. Zookeeper also, here we can see that KubeDB actually creates these resources when Zookeeper is applied. Then Solr So when we run Solr in Solr cloud mode, we need a zookeeper to coordinate the Solr cluster. And then here, when user actually deploys Solr in the Solr custom resource in the cluster, then provisioner operator continuously watches it. And when provisioner operator watches it, it actually creates some resources to run Solr in the Kubernetes. So in that case, we have stateful set services, role bindings, secret sub bindings, and PVCs as well. And after that, there is also a termination policy. This is a part of this is an attribute of spec actually. So there are specific values for it. First of all, if it's set halt, then secrets and PVCs will be retained in the cluster. In case of delete only secrets will be retained. And if it's wipe out, then no trace of the data and database resource will be remain in the cluster. And in case of do not terminate, that it will reject the deletion process. So after that, now obviously we need KubeDB in our cluster to all these operations. We can install KubeDB using this helm command. You can get this in KubeDB documentation as well. So now I will go through the live demo. So I hope my terminal is visible here. So currently I have an empty cluster and there is nothing here. So first of all, I will apply Zookeeper there. Share it again. Okay, so I hope my terminal is visible there. So first of all, I have to apply a Zookeeper there actually, since it's needed to coordinate the Solr cluster. So now we can see that the Zookeeper pods are coming here. So it may take 40 to 50 seconds to get to the ready state. In the meantime, if we get some pods running here, we will apply Solr as well. Okay. We can apply the Solr here. So we have got the pods here. Currently, need container is running. We have our Zookeeper in the district here. Okay, so we have both Solr and Zookeeper in ready state now. So now we can apply the ops request one by one. First of all, we'll go through the vertical scaling ops request. So if we see our vertical scaling ops request, we can see that there are certain attributes here. First of all, the database reference, we have to refer the database that we are going to apply here. Then we have type of the ops request, which is vertical scaling, and then we have a spec dot vertical scaling here, and under it we have some subsections again that are Solr in the topology mode supports 3 different clusters. So there are data overseer and coordinator who will have different pet set or stateful set for all the different types of data. So now if I apply it, then all then memory and CPU of all the ports will change to the certain amount declared here. So now if we check a port, that what is the current CPU and memory have there. So yeah, currently we have 2 gigs here and 900 millicore CPU. So now if I apply that vertical scaling, so you can see that our ops request has been applied here and it's in the progressing state now. Then now one by one Solr pods will take restart. After a successful restart, we can check either the memory and CPU of that pod has been updated or not. Okay, we can see that a pod has successfully taken restart now. If we just check the CPU and memory of that certain pod, here it is. Its CPU and memory has been updated. It was 2 gigs and now it has 2.5 gigs there, and the CPU has also updated to 1. So in the same process, all the pods will take restart and memory and CPU will be updated for all the pods. And eventually this progressing status will be converted to successful. And we also have to make sure that DB is also ready after the successful ops request. Still one port to restart there. Okay, so we can see that the status has been converted to successful and DB is also in the ready state. So we can say that our vertical scaling ops request has been completed successfully. So now we will go through the volume expansion. So if we get the YML of the volume expansion, we can again see that this is the spec for volume expansion. So obviously database reference and type is a common field, and here type is volume expansion, and mode is offline. That means pod will take a restart before expanding the volume of the pods. And we have also specified the memory, and we have also specified the space that we want to take in the PVCs. So if I just apply it, now we can see ops request has been created here and it's in the progressing state now. Again, one by one, all these pods will take restart and we have to wait till this progressing state converts to successful. And we have to also ensure that we also have to ensure that all these capacities are also updated. Your data pod is taking restart here. So after this successful restart, this capacity for data, this capacity of this particular PVC, that's our data 0, should be updated to 11 gigs. There it is. We can see that capacity is updated to 11 gigs, and here is our pod again. Same process will go for overseer and coordinator as well. There it is. Capacity updated for overseer PVC as well. What to restart here. This is our capacity of the coordinator pod has updated here. And here we have the coordinator pod as well. So only to be successful. That is our ops request is successful here, and DB is also ready. So after this, we will go to the horizontal scaling. It will deal with the number of pods in the cluster. So first of all, if we check here, so here we have one for each. We have also one. So if we want to scale it up, so first of all, I have to update it a bit. I have two for all the different bit sets. We apply it. Basically, it's actually quite simple. Same for database and type, but in case of horizontal scaling, we have to mention the number of pods we want in our cluster for different cluster types. So we can apply it. Now, no pod will take restart here, just a new pod will come. Here it is, we have a new data pod here. It waits to make sure that pods are taking connection. We can and yet another one pod to be unleashed here. So yeah, we have all got all the pods here. So very soon this progressing will be converted to successful. But again, we don't want that much pods in the cluster. So we also have downscaling support here. So what actually we just do is we will get back to our previous state, just one replica for all the cluster types. And yeah, here I have to actually delete that request so that I can apply it again. If I apply it again, now again extra pods will be evicted. Here is this data pod is generating here. After each eviction, database actually checks either it's accepting connection or not. Here it is, our overseer pod is terminating. overshare pod is successfully evicted there, and still we have another pod to terminate. Here it is, our extra coordinator pod has been evicted as well, and very soon this processing state will become successful. PVC also removed, and finally we have our status successful here as well. So this cluster is not TLS enabled actually. So we want to make this cluster TLS enabled for security purpose. So in that case, we have reconfigured TLS object request. In this object request, we can add TLS in our cluster. So here, same database reference and the type is same. And besides, we have a TLS where we are providing the TLS configurations like issuer reference and certificate information. So if I apply it here. So again, a new obstacle has been created here, and all these reports will take restart. And eventually we will check either our cluster is accepting HTTPS request or not. What has started restarting. So we have to wait till all three boards take restart, and after that, this progressing state should be converted to successful. So here all three pods are running and our status is ready. Now we will check that either it's taking HTTPS requests or not. So here it is. It's taking HTTPS requests. Our status is 0 here. So, and now if we try to apply curl HTTP request here, that is not supposed to work. Here it is. It will not work there. So in the same way, we can all now we have TLS in our cluster, but we can also disable TLS as well. In that case, if we want to disable TLS, we have to apply remove TLS here. So this is also same type, but in this case, in the TLS section, remove is declared true there. And after this, if we apply it, then after this ops request, TLS will be disabled again. So now I will go through the reconfigure ops request. So here it is. We have an apply config here. Now we have a default configuration in Solr already. If I check that, so here it is. This is the default configuration of Solr, but we want to update it. We want to update it with this one. So this two section here it is Solr.xml, which is an attribute, which is basically the name of the configuration file here. So if we apply it, these two JSON files will be merged actually. So to ensure it, we have to apply it. If I apply reconfigure ops equals there. Okay, now this pods will take restart. So if I check the configuration in this pod, here it is. We can this backup block wasn't here actually beforehand. It has been merged, and after that it is visible here. And besides, we have another attribute which we wanted to change. That's here 2024, and that's also changed there. Now we have to wait till this progressing state changes to successful. We have to wait till DB status is ready. Here it is, or DB status is ready here. So now we have a final ops request there, which is actually version update. Now we have different version supports there. We have 3 different versions. Latest one is 9.6.1. So we just want to upgrade to that latest version. So in that case, same for database reference and type, we have update version type here, and besides, so we have an update version spec, and under which we will have our target version, which is 9.6.1. We apply this update here. What says started restarting there. Our ops request is successful there, and we have to wait till DB status changes there. There it is. DB is ready there. So that's all from live demo. So I have to stop sharing a bit more.
So the audience, thanks for being with us. You can let us know if you have any questions. So we have come to end to today's webinar. Thank you all for the participation, and we look forward to your presence in our future sessions. Visit our website appsco.com/webinar to check the schedule and register for our upcoming events. Wishing you all a great day. Thank you.